Turns out the technology we've already got is perfectly adequate. We can definitely run the globe, not only with our current energy needs, but our future energy needs, on zero carbon with current technologies. And then there's the first solar road in Normandy, which I spotted. Now there's hundreds of these things, actually laying them to experiment and see what the economics look like, and they do work. And if you can make it work in Normandy, where it's cloudy and it rains all the time, you can make it work just about anywhere. And now people are thinking differently about that. You've got wireless charging with vehicles. You can charge them on the move, it turns out. You can do it pretty efficiently, as it turns out. That's a sort of a brain-snapping thing to think about. And you're saying, well, hang on, that's not very efficient. You've got to carry big batteries. Well, other people are going, well, let's do public transport and let's take the battery out and just put a capacitor in. Now, capacitors suck because they leak. They don't store that much charge, but they charge quickly. Biofuels today are absolutely woeful. They're zero carbon in that they grow, they take CO2 out of the air, but then we burn them and they put it back. And so it's supposedly carbon neutral, but none of that accounts for harvesting and transportation. And they're also terrible because they take up so much arable land. So they're awful. Biofuels today are absolutely awful. The future of biofuels is also very, very local and distributed. But it is extremely potent because it's methane, and that's much worse than CO2. It contributes to something like 4 to 6% of global greenhouse emissions, just ruminating animals. So it's a big problem, and that means big money. You'll also be hearing a lot about carbon capture and sequestration. Now here, one of the leaders, perhaps the leader in the world, is this guy, David Keith. He's a professor now at Harvard. He used to be a presidential advisor. He's got this program up to build this huge carbon capture device. Quite extraordinary, isn't it? If you look at it. This is conceptual. They do have a smaller version. I've got photographs of that, but I love this conceptual one. And the idea is, of course, you drive air through it, you sequester the CO2 in pellets and bury it underground. So I spoke to Professor Keith a little bit earlier this year about where it's at and how quickly it's progressing. And so what they do is, as a service, they will use the infrared spectrum to actually look at who's releasing methane and to quantify it, and who's releasing CO2 and to quantify it. They'll look at your power plant, your mine site, anything you wish. Now this is, from a sustainability point of view, the holy grail. We've been trying to do fusion for 50 years. And here's a schematic of a power plant. You can see a little figure down the bottom over there. This is a 23,000 ton machine. That's what it takes at the moment to smash hydrogens together to make helium, to fuse them together in the same process that takes place in the sun. Here's another way of thinking about it. So Microsoft just pulled up a data center from the ocean floor. So they've been running underwater data centers. Who knew, right? And what they're doing it for is, of course, last year, actually, we had some installations going below the 3 cent per kilowatt hour barrier. It's not stopping. It pays back in about 6.5 years. And after that, it's $11 trillion pumped into the economy on the positive side of the ledger forever.